Greetings everyone, welcome to lesson 1 of trigonometry for students and surveyors. We'll get to the triangles. We're going to start with right triangles, of course. That's pretty much the basic, most important types of triangles. Eventually we'll get to right triangles, curves, horizontal curves, vertical curves. Want to talk a little bit about why it's called trigonometry for students and surveyors. Students need to know trigonometry, and I think some of the best way for them to know it is to see what surveyors use. Surveyors use trigonometry every day in their work. Now we have things called data collectors that do all the processing, and all the trigonometry is internal in that. You just push buttons, but it's good to know exactly what's going on and what's going on inside that data collector. And for the students, instead of it just being abstract, something that you're studying for a test, by seeing what surveyors and how often, every day, all day, how often we have to use trigonometry, then also how much trigonometry surrounds your life. The roads that are built, the sidewalks, the sewers, the storm drains, the house roof pitches. It's just everything and anything anything that isn't wild land has been surveyed in and built with construction, and the surveyors show construction people where to build, what they're going to build, how deep to build it, on the elevations, everything. So they go hand in hand, and geometry is another, basically, and trigonometry go hand in hand. So before we get started, and I'm going to need, Polly, I'm going to need that other calculator.
Yes.
I am going to show you some of the stuff that we're going to need here. It would be pretty nice to have. You're going to need a calculator, and we have always used the HP 35S right here. Very good calculator. These are RPN, reverse Polish notation. You don't have to use a reverse Polish notation. What that means is, instead of going 2 plus 2 equals 4, you just go 2, enter 2 plus. It seemed a little confusing at first, but when I got into this business 25 years ago, every surveyor had an HP calculator. I think the versions before this, 41s, 40s, 42s, 33s, 48s, there's lots of different ones, but they were all HPs, they were all RPNs, reverse Polish notation. These allow a stack of numbers to go up in, and then you can do really long, complex equations without having to use parentheses and so on and so forth. They're just very wonderful. They do everything the surveyors need, trigonometry need. We can convert hours, minutes, seconds, or degrees, minutes, seconds to decimal degrees to work the problems, and then when we're all done with working the problem, we convert back. There's usually a polar rectangular feature in there. Sine, cosine, tangent, and their corresponding inverse function is arcsine, arc, cosine, arc, tangent. So we're going to get to that in a minute. They don't make them anymore. What I found out now is, when I was teaching the same class at Lake Washington Institute of Technology for 3 years during the winter courses, and I had everybody buying an HP 35S. They were $59 back then, so it was well within everybody's budget. So then I had people that, when that quit because of COVID, they shut the campus down, so that was the end of that. Never started up again. Anyways, long story short, HP quit making these, I think, because they're just not selling much. Everything's computerized. Surveying, it's the data collectors on the office, it's computers. Engineers use programs and so on and so forth. I think calculators are a thing of the past, but they're really, really nice to have. So if you can get one, if you can come across an HP or Texas Instruments, whatever brand you want, that'll be fine, as long as you know you're going to have to know how to use it. Another thing that's really handy is the memories. You can store memory in just about any key. So we'll go through all that later. Prior to that was the HP 33S. Same thing, a little different layout, a little different visual of it. just as powerful, just a great calculator as well. So I was going to have and encourage you all to get these calculators, but since they don't make them anymore, and very few calculators have, oh, there's well, we'll get to that in a minute. There it is. There's a free download. It's called 42 free 42, and you can download it for an iPhone or a Samsung, and it's the HP 42S. It's basically the same thing, and so here's that. So I would recommend do that, and you can download in just a few seconds, a few minutes, get this thing in here, and I'll go quickly through. It's almost exactly the same thing. When you store something, so you have to convert. You have to convert, and there's your convert button. There's HR, which is decimal degrees. HMS is degrees, minutes, seconds. So you'll have to look at it, but it's this orange shift key, and convert is over the white. And I'll show you how to do that. We'll go through that just about on every single one. And you also have your sine, cosine, tangent, and above that, the shift key, arc sine, arc cosine, arc tangent. And then finally you'll have, let's just exit that. You'll have, let's say 56, enter, and then you want to store. You can store that wherever you want. I'm just going to store this with an 8. And then you have to hit, the difference on mine, you just hit store 8, or store wherever you want to store it. You're done on the HP 35s, HP 33s. On this one, you hit store where you want to store it, then you have to hit enter. All right, then you can go out of there, go 96, enter, 78 plus. Okay, now we want to recall that one. Recall, that stores over here, recall 8. Now you have to enter, and there's that 56 again. And you can hit plus, and they added those all together. Very handy to have. 42S, get very familiar with it, because we're going to use this. And then, like I say, I will be speaking both in RPN, reverse Polish notation terms, and the regular algebra terms. So I'll try to word each, as much as I can. But it's easy for you to follow and figure. It should be easier to follow and figure out how to do these things. Just anytime you get something like this, just get yourself familiar with it. And one of the things I wanted to bring up too is when we're working with degrees, minutes, seconds, we converting back and forth. Well, let me just jump ahead here. When you're doing this stuff, you can use paper. You should just get some graph paper. Another items you should have is graph paper. Get yourself a tab of graph paper. I have both this size and then the bigger stuff too. So I have a big drafting board. And then you can get a compass, either a half compass like this, big full size compass, or not compass, sorry, protractors. I'm losing everything. Protractors, so that you can put those on there. And you want to read your protractor, you want to be able to read it both directions, because you're going to do angles both directions. Then you can draw your triangles, check your angles with your protractor, and it's very handy. And then you can just practice and get good at it. You want to practice. You want to get very fluent with these right triangles, and we'll get going on that in a minute. Because when you take your test, you don't want to stumble on things that you probably should be very routine. So you want to make everything very routine. So you want to scale too. This is an engineer's scale. Everything we do is going to be mostly, not always, but mostly base 10. So these scales have 10, 20, 30, 40, 50 scale. Then you can use the scale on your graph paper. Just pick the scale that you want. 50 could be equal 50 feet or whatever you want to do. You can use whatever scale. What I would recommend is go your scale, make sure you write it on your graph paper, 1.20 or 1.50, so that when you set your scale down, do some calculations, and then you're going to check your distances, that you don't pick it up and get the wrong scale and say, well, that doesn't work, that's not right. So if you write the scale down, then you'll say, okay, oh yeah, that's right, it's 30 scale. Then you can, that saves a lot of confusion. I'm going to belabor a lot of issues here just because I know I've made all the mistakes 100 times myself, so I know how to, I kind of know where to look for those mistakes. Good mechanical pencil is nice to have. What else? That's what I was going to show you. And when you're doing the angles on the graph paper, when you're practicing at home, you could just use degrees to start with and forget the minutes and seconds until you get good with that. But I wouldn't recommend doing that for too long. Eventually, we're going to start including minutes and seconds and converting back and forth and back and forth. Because if you forget if you don't do that, if you're not fluent with doing that, when you get to your tests, you're going to forget to do that. You're going to forget how to do that if you just work with degrees. If you're working with degrees, there's no conversion. Degree is degree. But minutes and seconds have to be converted so you can work them as a digital. So we'll do that with the calculator later on probably lesson 4. I believe lesson 4, I'm going to show you how to do that long-handed, just so you can kind of get an idea of how that works. So we'll do that. I'll use my calculator on this. And one other thing I want to show you about. This is this surveyors and engineers, it's called an engineer's tape. It's not metric, but what it is, it's base 10. So a foot's a foot. On the bottom scale is 12 inches equals a foot. On the top scale is 10 tenths equals a foot. So all surveyors, as far as I know, in the United States, Canada uses metric, of course. So does the rest of the world. We use our system. It's called the U.S. survey foot. Broken into tenths. The tenths are broken into tenths. The tenths are broken into tenths, and those are broken into tenths, and then those are broken into tenths. So we fix our calculators. That's called fix. You go in and find out where that's at. Fix 4. You want to fix it 4 points, 4 places right of the decimal. So you have tenths, hundredths, thousandths, and 10,000ths. And that also gives you room for minutes and seconds. That's really the thing. So, and those are tenths, hundredths, thousandths, and 10,000ths of a foot, not of an inch. A machinist that machines car parts and so on and so forth, they use tenths or hundredths and thousandths of an inch. So they're finer yet, but this is pretty fine. Now the construction guy, it just makes it so much easier when you're doing construction work, when you're doing stuff. Everything is basically a base 10. So you're using metric. When you're drawing your stuff out with your scale, it doesn't matter. We're not going to use fractions of an inch, 16th, 32nd, 64th, whatever that is. We're just not going to do that. All right. What else for equipment? Just let you know that these calculators do trig tables. They do trig. And they also come, well, you're not going to get a calculator anyways. I was going to show you the manuals and the disc. If you can find those 35s or 33s, snap them up. There's also a guy, EasyCogo. It's easycogo.com. You can look there, and he can program these 35s for a complete survey program that does just about everything a data collector will do, plus hydraulics. They used to be with the data collectors $300 and something now, because they quit making these data collectors. You can still get them, but you're gonna have to pay a pretty astronomical fee for them. So I think the answer there is, I think we should all get together as surveyors and students and try to get HP to restart to make those again, those HP 35s. I know they're not going to make money off of it, but it would be a great public service, a great big corporate PR positive movement for them. So in survey books, you literally have what they call trig tables. There's just page after page. So when they're converting, they're using these trig tables. And now we have the data collectors, or we have the calculators to do that, so it saves us a lot. But And then the data collectors do everything. They do road programs, they do stake by line, they'll do stake slopes, whatever you want them to do. You just have to know which buttons to push. The people that do that don't really know what's going on, that don't really know exactly what those functions mean, we call those button pushers until they show that they really want to learn and be experienced at it. They don't know, so you don't really know if you're getting the right answer or not. If you can pull your own calculator out and check your work, that's pretty nice. So there's an old book too. So, all right, protractors are very handy. And let's get back here. It's okay. Now I'm going to keep my calculator handy on me. All right. This is my calculator. I'll give you a close-up of it. Okay, so what you want to do, a right triangle, very handy, got to know right triangles. This is going to be, so you want a memory device is to figure out the trig functions on a triangle. Is this terminology here, or this kind of a word, is called SOHCAHTOA. A lot of people use that as just a memory term, SOHCAHTOA. And what that means is sine is the opposite over the hypotenuse. And then we'll go through that. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. And here they're written out, they're broken out. Sine, opposite over the hypotenuse, and so on and so forth. So what does all that mean? Over, well, like I say, I don't want to insult anybody's intelligence, but over means that's division. It's just simple division is what that is. So let's break that down. So opposite of what though? Opposite of what? So anytime you have a triangle, a right triangle, or any triangle, you have the angle and the opposite side of that angle. So the angles, you always write those in uppercase. So we're going to call this angle A. It doesn't have to be called angle A. You could call it angle C if you wanted. But the opposite of that is lowercase a. So here we're going to call this angle B. And the opposite is B, and we're going to call this one C, uppercase C, lowercase c. So the opposite is the opposite of the angle, so this one here that's the opposite of that. So to identify a right triangle, you really have to understand the point of perspective that you're talking about here. We're going to deal with A. B will have a different set of stuff. So that's all memory device. That's all memory to help you remember. You got to remember these: sine, opposite over the hypotenuse; cosine is adjacent over the hypotenuse; and tangent is the opposite over the adjacent. It's the adjacent to this angle right here, A. So we're only dealing with A now, we're not dealing with B at some point. So now let's come over here, look at this. Now I've taken this triangle and I've blown it up into its three components, into these three components. Now your sine is the opposite, that's here, that would be A over C, because we're still looking at this angle perspective. This is all from angle A. I'll just write that in, uppercase A. Okay, now your cosine is your adjacent over your hypotenuse. So that's what that would look like. This is so you can identify a triangle, a right triangle, and know which function to use, whether it's sine, cosine, or tangent, or whether it's arc sine, arc cosine, or arc tangent. one more thing, in some of the calculators, these literally say arc. Let me pop that up there. They're in the blue shift. So under sine, you have blue shift, and it's arc sine, and so on and so forth. Sine and arc sine, cosine and arc cosine, tangent and arc tangent are inverse functions of each other. They just flip back and forth. On some calculators, and it's fine to use those, even some of the old HPs, instead of saying arc sine, it has an I. It's an inverse, basically stands for inverse function. So this one's very simple. On some of those, I think I picked one up and I couldn't figure out how to use it, but I didn't have the instructions. But if you have one that has the I, you can do the same thing. You just gotta play with it, find out the instructions. Maybe somebody on the comments below that has that. So I think it's a little different, but it might be exactly the same. But it's the inverse function. So okay, so there we are. Now, if we were doing this one up here, we would have, this one would be a little bit different. Angle B, you would have the opposite over the adjacent. Well, it would just, you can imagine it would be, this would be the opposite of that. The adjacent would be A over C, or yeah, over C. And then the sine would be B and C. Okay, so that's the memory thing, but I have what I figure is a better memory, or helps, or in conjunction with that, another way to remember it. And I start with the tangent. Instead of the sine, I start with the tangent. The tangent has a T in it. Let's just write tangent. The tangent has a T in it, so the T has a right angle. That symbol is a right angle, so we're going to put that in here. Anytime you see that, you know that that's a 90-degree corner. So if you see two lines and they look perpendicular, they look for that, because they should have that. That means they're perpendicular, because some people, you just can't draw them perfect. But if you have that, take it to mean that that's a 90-degree. Okay, so that's that. So that's easy for tangent. To remember tangent, the word tan has a T. The T has a 90-degree. So the tangent is this guy right here. It's the square one. In a polar rectangular on the function of the calculator, these usually goes together, and then the polars go together. Same with, well, yeah, not with not. Okay. And the other one is easy to remember is the cosine. See, the cosine is the adjacent over the hypotenuse. Adjacent over the hypotenuse. That's the cosine. The reason that's easy to remember, see the circle? See the circle? They connect at the vertex, or at the vertex of the angle. It's spelled V-E-R-T-E-X, but it's pronounced V-E-R-T-I-C-E, vertex. So they connect. The confluence of a river is where the two rivers come together. They connect. So you can use that. That's another memory thing. So those are too easy. You got the tangent, and you've got the connect, where they connect from that angle. Now this here, the cosine, would be here, because they connect here. The tangent would be these two. Okay, and then sine is the last one that's left over. I don't have any tricks for sine, but that's the last one. Now, this is a 3, 4, 5 triangle. That's the other thing I wanted to teach or impress upon you. The 3, 4, 5 triangle is, this side is 3, 4, and 5. Now that's just happens to be the size of this triangle, but it's easy to remember, and it's a good one to know and to practice on, because once you have that in your memory, you can use that sort of as a virtual tool that you can carry around in your brain, that whenever you're looking at a triangle, they're obviously not going to be that dimensions, but you can look at it and say, okay, if this was a 3, 4, 5 triangle, I would do this, and I know that my answer would be 5, or I know my answer would be 3, or I know my answer would be this angle. So, okay, we're going to wrap this first lesson up pretty fast here. So what we have to do, first of all, let's use the Pythagorean theorem. So a squared would be 9. 3 times 3 is 9. B squared, 4 times 4 is 16. And C squared, 5 times 5 is 25. A squared, C, the square root of C equals the sum of A squared plus B squared. And that works in reverse too. If you already have this one, the square root of the hypotenuse minus the square root of one side or the other will give you the answer to the missing side. Okay, so A squared is 9, B squared is 16, equals 25. 25 minus 9 equals 16, 25 minus 16 equals 9. So that's, we're not going to use that too much, other than we're going to use that to check triangles. So that'll be, that's where we're going to use that as much as we, as much as we do use it. And that's about that. Now, let's work some of this out. So, all triangles, whether they're this shape, non-right triangles, excuse me, are add up to 180 degrees, the interior angles. All add up to 180 degrees. It doesn't matter what shape they're in. We'll work with that in a minute. If you had a 60 equilateral triangle, all sides are the same, all the angles are 60. So, so the formula for that is interior angles, or the number of angles. There's 1, 2, 3 angles, minus 2 times 180, and that gives you that. So that gives you 180. On the exterior, it's the number of angles plus 2 times 180. Okay. I'm gonna get some water. Wow, I'm dry. I can cut all that out, you know.
Mm-hmm.
How are we doing for time? 8 minutes left. That's for a half hour? Okay. And roll them. All right. We have 3. Let me erase these. We're back. And 4. So let's go back to our formula sine. So we're going to get this angle here. We're going to solve this angle 3 different ways, with all 3 of these different ways. Boom, boom, boom. All right. We're going to go, and here's how you do that. Opposite, or the sine is, or we're going to go, we can go with the sine. Opposite over the hypotenuse. So 3, so remember it's division. 3 divided by 5, and then divide. Now 0.60, that's the ratio on this one. And we're just going to put that over here, 0.600, 0, and so on and so forth. Okay, now we've got, that's the ratio. This line is 0.6 as long as that line. And now what we're going to do is, yeah, I should wait. I'm going to wait on that one. I'll come back to that one. The cosine, no, let's do the tangent first. I always like to do the tangent first. Let's do that. I got thrown off course. We're going to do the tangent first. That's the opposite over the adjacent, 3 over 4. So we're going to go 3. Now you're going to go 3 divided by 4. I'm going to go 3, enter 4, divide. You're going to go 3 divided by 4. You're going to get 0.75. 0.750. That's the tangent. That's the ratio. This line is 3/4 as long as that line. That's all that is. And now, so now what we want to take, this is where those trig tables are in the book. This is what's in here. Figuring out longhand, I don't know too many people that try to do that. They either get them out of the tables or they get them out of the calculator, or the data collector does everything for you. And same with computers on your office, they do everything. They do all that. So 3, 4, that's your ratio, is 0.75. So now we need to find out that arc. So now we're going to go into arc tangent. Because we're using the tangent function, we want to use the arc tangent. Makes sense? So we don't hit the big white key that says tangent. We hit the shift key, shift, tangent, and we got 36, 86, 99. Now that's the digital. So I'm going to write both of these here. So we're going to go, I'll write it right here. 36 decimal 86, 99. Now I'm going to store that down here at 0. So I'm going to go shift key, store 0. Now just to make sure it's in there right, I'm going to go recall 0, 36, 86, 9. Now I'm going to convert it to hours, minutes, seconds, or degrees, minutes, seconds. Now this is the orange shift key, and on this one it's above the 8. On the free 42, it's convert on key number 5, I believe. And yeah, let me have that one because it's probably the one you guys can use. So we're going to go 0.75 and arc tangent, 36, 86, 99. 36, 86, 99. Now we're going to convert that to degrees, minutes, seconds. So on this one here, you want to go shift, and there's convert is right above 5. Orange shift key, convert. Now you want to go up here, and we want to go to we want to go to HMS, 36, 52, 12. Right now, 36 dash 52 12. Another way to write that is, I'll write it over here, 36 degrees, 52 minutes, 12 seconds. Okay, so that's what you do. And then on this one, you'd store that somewhere so you can use it. So we'll go store, we'll go 0, enter. Oh, okay, so now we can convert that back to HR, 36, 86, 99, and we can store, I don't know that yet. We just want to go store, we'll store 0, enter. Recall 0, enter. So by hitting the enter, gives you an extra keystroke each time rather than this, but it's not a big deal. Thank you, Pauline. All right. So there, we got that. And this is what you'd work with. If you're adding angles, if you're doing a traverse, if you have a polygon, you have many angles, you add all this up. When you're all done, then you convert it back to degrees, minutes, seconds. And like I said, if you're working with your protractor and your graph paper, just use your angle or just use your degrees. Forget that until you get more conversant at it. You get a little handier at it. Okay, so now we're going to try to find that same thing with, let's use sine. So it's the opposite or the hypotenuse. So we're going to go 3, enter, 5, divide, that's 0.6, which we have. Now we want the arc sine, because we're using the sine. It's simple. So arc sine is 36, 86, 99. So we have that. So we'll just put a check there that we've checked it with the other one. And that's how we do it. Now we have the cosine. Here's the cosine. Last time we did the sine. Now we're doing the cosine right there, adjacent over the hypotenuse. 4 over 5. 4 over 5. So 4, 5, divide, and we have 0.80. That's the ratio. So this line is 0.8 as long as that line, or side. We'll call that a side, or line. They even call them rays. Okay, so now we're going to do arc cosine. So shift key, arc cosine, 36, 86, 99. There you go. So we've done it every way, and that's going to be our first lesson, and then we'll go into lesson 2, and we'll do these all backwards and forwards, and we'll keep doing these as we go along. So that applies to up here. And now one other thing, we can do that since we recalled that. We'll recall 36, 86, 99. I hope you guys stored it. That's why it's always nice to store it. Now we're going to add 90 degrees to that. So plus 90, or 90 plus. You got 126, 86, 99. And now we know the whole thing is 180 degrees, because all triangles are. And so we'll go 180 minus, or minus 180. And this one up here is, I've got to take off my negative sign, 531301. And that also equals, we'll shift it, 530748. All right, we have all of the triangles solved. We have all the angles solved. And we will do it backwards. From now on, we'll do it we'll occasionally go with the angle and one side. So to solve a right triangle, you need 2 sides, or 1 side and 1 angle. Then you can solve them all. And one more thing before we close up here, degrees, minutes, seconds. There are 60 minutes in 1 degree. There are 60 seconds in 1 minute. Do the math and you have 3,600 seconds to 1 degree. That's getting pretty tight, pretty fine. So that's going to be it for lesson 1, and stay tuned for lesson 2, or come back for lesson 2. What's that? Oh yeah. Okay, that's it. Stop.